right, this problem number 2 says a bus line carries 2,000 passengers per day at a rate of 20 cents per passenger. Management wants to make a rate change, and they estimate that they would lose 200 passengers for every 5-cent increase. So what rate should they charge to maximize revenue? So we want to first come up with some equations for these rate increases, and let's come up with some variables as well. Let's say for every 5-cent rate increase, let's say the number of these, let's call that Y. The number of 5-cent increases, let's call Y. And let's call the number of passengers X. All right, so the number of passengers is X, the number of rate increases is Y. So first of all, we know that so let's talk about how X and Y are related. X is going to equal, remember, X is the number of passengers. X is the number of passengers that I have. So the number of passengers that I have is going to be related. It's going to be 2,000, because that's what I'm starting with, minus 200 people for every rate increase I have. That was one of the tricky parts to this, is try to find that equation. So that's that one equation that I have. Now I need to find another equation, and that other equation is going to be my profit. My profit is going to be the number of passengers I have times the rate per passenger. And what is the rate going to be equal to? So I'm going to make another equation. The rate's going to be equal to 20 cents, because that's my starting rate, plus 5 cents for every Y. That's what my rate is equal to. All right, so now that I have that rate, I can substitute that in here. So really what my profit is going to be is equal to X times the rate, which is 0.2 plus 0.05 times Y. And now I'm going to take my equation relating X and Y together, and I'll plug that in. I'll actually just plug the Y in for X, and that's going to give me my profit in terms of just Y, which will equal 2,000 minus 200Y times 0.2 plus 0.05Y. And now I can see that I have a quadratic equation with a negative leading coefficient, which means it's a parabola opening upside down, and all I need to do now is find my negative b over 2a, which is the x-coordinate of the vertex, to find out, or in this case the y-coordinate of the vertex, because y is kind of my x here. I probably could have done a better job labeling my variables x and y, but regardless, that works fine. So let's do that work. So simplifying that gives me this quadratic equation. So that's plus 60y plus 400. You can factor out a 10 if you want. So that would be negative y squared plus 6y plus 40. And so my negative b over 2a is negative 6 over 2 times negative 1, which is positive 3. So 3 is my x-coordinate of my vertex. So 3 is going to maximize that, and that's my y. So that's it. That's what I want. Y equals 3, which is the number of rate increases. So what rate should they charge? Well, if there's 3 rate increases of 5 cents each, what's the rate that they're going to charge?
35 cents.
Yep, 15 plus 20, which is 35 cents. 35 cents is your answer.